Hello everyone, welcome back. This is the Calculus 2. So in this video, we're going to talk about 3.7 improper integrals. So let's take a look at the concept of improper integral, what it looked like and what does it mean to you. So we have a very interesting, integral that we are going to deal with in 3.7. In general, we know how to describe the integral symbol. So it looks like this. Let's say let's say if I'm taking integral, the function f of x, it means you're looking for the area. We don't know what kind of function we are going to talk about. It could be linear, it could be quadratic, trigonometric, it could be very, different type of function, and we are looking for the area a to b. So this integral means that we are looking for or estimate the area from a to b. So in this case, we have a specific interval from a to b to evaluate that area. What if we have infinite interval? Okay, so for example, you have a function f of x everywhere, and then the interval gonna get involved with infinity. So let's say from a to infinity, or negative infinity to b, or from all negative to the positive infinity. So you can think about the case. The first case could be, so we have a 3 scenario. So the first case, you have a function. I'm looking for the area from a all the way up, keep going, never ending, because we are keep going up to infinity. How would you be able to find out the area? Correct? Second case, what do you guys think? We have in a function, and then you stop at b, but then you came from all the negative infinity. How would you be able to find out that area? We don't have a specific interval from a to b. One of the interval with, improper integrals, we are going to have infinity interval. Or the last case, everywhere under the function, from positive infinity to negative infinity. What is that area? So we call, this type of integral that involves with infinity, it could be positive or negative infinity. We call that as improper integrals. So you're gonna deal with 3 cases in this chapter. So we are trying to find out the area. That's our goal anyway. So I have 3 cases. So the idea is pretty simple because we know the background. We know the story where the integral came from. This came from Riemann sum. Do you remember? So in general, when you have a specific interval a to b, we create many infinite number of the rectangular. So you have summation all the area of the rectangular and take the limit. So we're gonna utilize the limit to find out, to estimate the area under the curve, although you're gonna see the infinity. So here's the first case, right? The first case is from a to infinity. So by taking the limit concept, so a is still there, but then now I'm gonna, instead of writing infinity, I'm gonna say r and take the limit. We know where r is heading to. R is approaching to infinity. So by taking limit, you might be able to estimate the area of the function from a to infinity. So the key point is you're gonna take the infinity, and this is from including a all the way up infinity. Second case is from negative infinity and stop b. So same thing, you're gonna fix the b. B isn't like including number, but then you're gonna use another letter r, because that's something getting involved with the infinity. So r is approaching to the negative infinity. So it's the same meaning. The left and right side, they're talking about the same meaning. Just I'm taking limit to evaluate that concept, because the limit helps us to find out the outcome, because we don't know how to take the integral. Okay, so this is from negative infinity, b include. So what I'm saying is, from this observation, we are going to evaluate the limit. Okay, because the limit help us to find out whether you have exist the limit or no. So if your limit exists, okay, that means this integral is going to be converges. And then the other case, if the limit does not exist, let's say either go to negative infinity or positive infinite, then we're gonna say this integral means diverges in integral. So that's why in each case, if limit exists, then improper integrals say to convergence or converges. And then if limit does not exist, improper integral we say diverges. Okay, so we are going to basically take the limit. Okay, so by taking limit, you will be able to find out the outcome. If it exists as a number, that means it is a converges, and then if not, it's a divergence. So that's the 1 and 2 cases. We're gonna show you all the step-by-step work. The one last question. The infinity from negative infinity or into positive infinity. So you have a 2 scenario. So we're gonna have a specific number 0 between. So one is from negative infinity to 0. That's 1 term. So from negative infinity and you stop at 0. And then the right side is going to be you're gonna from 0 to positive infinity. So if you're adding them up, that means it's from all the negative infinity to positive infinity. Does it make sense? So in this case, we are talking about negative infinity to positive infinity. And then how do I know whether it is a convergence or divergence? To become a convergence answer, both A and B must have existed limit, okay? So if A and B, both the term, I'm saying this is A and B, if both convergence, the answer is a convergence. If one of them is divergence, automatically the entire answer will be divergence, okay? So that's the improper integral, very, very understandable concept. I'm not saying it is easy, but it's a pretty understandable. You are going to deal with, integral, especially when the integral is getting involved with the infinity. So we have a 3 scenario from A to positive infinity or from negative infinity to the B or entire negative infinity to positive infinity. How would you be able to find out the area under the function? It's the same question. And then you're gonna take the limit, we're gonna evaluate the limit. That's a key point. And then make sure those are, specific, symbols for each case. And that if the limit exists, then it's convergence. Otherwise, it is going to be divergence. Okay, so let's take a look at the question and then you feel like more confident. So here we go. Example 1. So determine whether the area between the graph of the function. So this is the graph as a given. F of x equal to 1 over x. Okay, so they're looking for the area from 1 to positive infinity. They're all the way going up, keep going. So we have a 3 scenario. So this interval is going to be matching with number 1. Am I correct? So you can rewrite it. This is improper integral. So that means you can write it from 1 to positive infinity. The function is 1 over x dx. That's what we are looking for, that area. Okay, and then because we don't know how to take the integral with the infinity, we're going to convert it to the limit. So that means the same limit, right? R approach to the infinity and where 1 to r, the same function and dx. Are we okay? Now you can take the integral, then you can take the limit. So step-by-step work, just some corresponding what the given information. So now what happened? If you take the integral 1 over x, Do you guys remember 1 over x? It is going to be ln x, correct? And then we have area from 1 to r. You're gonna take the limit r approach to infinity. Okay, keep going. I'm gonna make a little bit smaller. And then that means what? We are going to subtract r. We're gonna subtract, that means r minus 1. So we're gonna do that work. So I'm gonna keep limit r approach infinity, and here ln r minus, but it's gonna be absolute value, ln r minus ln 1. Are we okay? So that's a bracket. And the ln 1, we know it is gonna be 0. So this means the limit r approach to infinity, ln r. Okay, we got it. So now what happened? So to evaluate the limit, the basic work to evaluate the limit is a direct substitution. So you're gonna substitute infinity into r. Let's check it out. It is ln infinity. Oh, this is infinity. This is not convergence because the limit is approach to infinity. So the answer is going to be, this is a diverge. The area under this function from 1 to infinity is getting large and large and large and large, obviously, because it's getting larger. So it is going to be divergence answer. That's your answer. How you feel? So I'm going to hold up here for a second. Think about it. All right. If you got this one, let's take a look at a couple more questions. So let me write down one more time the difference between converge and diverge. So an improper integral is say to converge when the limit exists as a real number. Okay, then it's gonna be converges. Sometimes no, it's a diverges when the limit does not exist as a real number. So it's gonna get involved either negative infinity or positive infinity. And then we're gonna look at those 3 cases. All right, here is a second example. So now you are getting better. Let's take a look at it. What is going on? We are looking for the function is x. This is a linear, right? This is f of x equal to x. We are looking for a linear function. It looks like this. F of x equal to x from 0 to positive infinity. So the area all the way go larger and larger. We know it's going to be diverges, but we're going to prove it. So this area means that infinity from 0 to positive infinity, x dx, which is the first case. So we can find out the corresponding limit. So limit r approach to infinity from 0 to r, x dx. Nice, nice. And then we're going to take the integral. That means x1 plus 1 divided by 2 from 0 to r. So this is going to be x to the second over 2 from 0 to r. So you're going to subtract large r minus 0. So if we take that work, so there's a still limit. So there's a limit r approach to infinity. So we are going to r square over 2 minus 0 square over 2. Are we okay? So then what happened? This is going to be 0. 0 over 2 is a 0. So we have limit r approach infinity, r square over 2. Now we are evaluating limit. So you're going to subtract infinity to the r. So infinity square over 2, direct substitution. That means infinity divided by whatever is still infinity. So therefore, limit does not exist. So this integral diverge to positive infinity. The area is getting larger and larger and larger as x getting increases. So that's how you are solving a type of, improper integral problems. Okay, we're pretty good, don't you feel? So we're gonna take a look at one more practice. Here we go. All right, what is going on here? So I'm gonna look at that. So we have x times e to the x, that's a given function. Oh, now we have an infinity from negative infinity to positive infinity. So this is the third case, if you look at that. So we are going to have, one stop from negative infinity to 0, one stop, and you have another area from 0 to positive infinity. That's what we're going to break down. So therefore, if we are going to do, we're going to check. We're going to check. So this is improper, so I'm going to write it. Infinity, negative, integral from negative infinity, positive infinity, x e to the x. Dx means, right, this two terms of summation. So I'm going to write limit r approach negative infinity from r to 0, x times e to the x dx, which is, I'm going to highlight it, which is this area. And then second, limit capital R, and then you are going to from 0 to r, x e to dx, dx, this is going to be second area. So we are going to adding those two so that you can find out from all the way negative infinity to positive infinity, correct? So if you can think about it, I'm going to just get rid of it. It means negative infinity to positive infinity area is the same as negative infinity to 0, adding 0 to positive infinity. Does it make sense? So we're going to work on this problem. So, and if you remember, let's go up. In third case, if you want to find out the convergence answer, both A and B terms should be converges. Then it's going to be converge answer. But one of them, if diverges, automatically the answer will be diverges. So what we're going to do, you're going to check one of them. If it turns out diverges, automatically it's going to be diverges. So we're going to do step-by-step work. I'm going to minimize a little bit. So I'm going to work on the first part, the first box, first term. So we're going to take the limit, r approach negative infinity, r to 0, x times e to the x dx. So we are going to take a limit first. Dun, 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 dun. Do you remember what is going on? This is 2 multiplication. So we're going to use integral by part method, IBP. So that means, do you remember? IBP means UV minus V du. You need to find out 4 important components. So x times e to the x has a priority to become u, function. So we're going to say here, so we have x times 2 functions multiplication. This is a product of two functions. So we're going to use integral by part. U equal to x. So to find out the u prime, du over dx is 1. So du will be dx. And then we already know this is a v prime, correct? So the v prime, which is a dv over dx. I'm going to move this one a little bit. This is e to the x dx. So to find out v, you're going to take the integral, which is e to the x. So we have all the 4 information. That's you need. We have a u, I'm going to highlight it. We have a u, we have a u prime, we have a v prime, we have a v. So now, according to the IBP method, so we are working on this integral right now. So therefore, according to IBP, u is going to be right there. U is x times b e to the x integral. B is going to be e to the x and du is a dx. And then don't forget that we have from r to 0. We have r to 0. So let's work on. So this is going to be x times e to the x. And then if you take the integral e to the x, it's going to be same, minus e to the x from r to 0. So x times e to the x minus e to the 0 minus e to the r, right? So therefore, what are you going to do? We are going to have x times, actually, I have a little bit of a mistake. Let me just get rid of this one for a second. This one has everywhere. So I'm going to just a little bit move to here. We have an interval from r to 0 everywhere. Don't you think so? So go back to the IBP part. So what I'm saying is, so I'm going to just get rid of this one for a second. I have to r to 0 everywhere. That's the interval. So we have to do that work. So let's try it one more time. So this one will be 0 e to the 0 minus r times e to the r, right? Minus e to the 0 e to the r. So this is going to be 0. So negative r e to the r. And then this is going to be 1 minus e to the r. So if you simplify negative r e to the r distributive property, we have this answer. So this is going to be the integral outcome. Now we are going back to the limit. So limit r approach negative infinity, we're going to plug in back here. Negative r e to the r minus 1 plus e to the r. Now we are going to evaluate the limit. So to do that, I'm going to make a little bit of space. So here, I'm going to bring this one all the way down, right? So we are going to take the limit of this. Let's separate it step by step. That means limit negative r e to the r plus limit r approach to negative infinity and negative 1 plus r approach negative infinity e to the r. So if you take the limit, what happened? So this is going to be, we're gonna plugging in negative infinity. So if you think about it, this is a little bit, I'm gonna bring negative to the front. So r e to the r. This one is gonna be anyway negative 1 constant. And then the last one, if you have infinity, direct infinity, so this means actually we're going to do the direct substitution e to the negative infinity, okay, which is going to be 0. So let's keep thinking about it. So it's going to, we're going to deal with the first part, limit r approach negative infinity. And this is a little bit of skill. You can bring this negative again into the exponent according to the exponent rule. So if you remember, like e to the negative n with the log or limit, you can bring this one negative n to the front. Something like that, it's equal. So what I'm going to do, this is the same as a limit r e to the negative r. They're same. Okay. And then we do have negative 1. And then e to the negative infinity, think about it. You are getting, if you go to the decimal graph, they're getting close to 0. Because that's a limit. As r is going to the negative infinity, they're getting close to 0. So that is going to be 0 anyway. And then we are going to take a look at this. Here, what we're going to do. If I plugging in negative infinity, this is indeterminate form. In other words, this one, if I rewrite it, r over e to the r, because the negative exponent we can flip over, and we have only -1 here. So this is if you're plugging in negative infinity, it's infinity over infinity, indeterminate form. Please use L'Hopital rules. So you're gonna take the derivative of top and bottom. So limit r prime e to the r prime, which means limit 1 over e to the r, because the r is going to be 1. Now you can take the infinity. So limit, if I plug in negative infinity, 1 over e to the negative infinity. This is going to be 0. So therefore, we have a 0 minus 1. We have a -1. So first term, we just found out that it is a convergence. So this is a little bit challenging work. So I'm going to show you one more time. So we know the concept, what's happening. So I'm trying to find out the first term, whether it is a converges and diverges. So to take the integral, I've been using the IBP method. So we got that is a -r e to the r minus 1 plus e to the r. Then I take the limit to see whether it is whether the limit exists or not. So when I did that, a little bit of work from calculus 1 that you learn. So you're gonna take a little bit of the exponent skills, and then we got that is actually 0. -1 is a constant, doesn't matter where you go, it's still -1. And then the last one, we got that it's actually 0. So we got that information, it's a converges. So this is actually converges. So we have to still check second part, because if it was divergence, the answer is divergence, but since it is the convergence, we have to see the chance of the second, whether it is divergence or convergence, right? So just remember the L'Hopital's rule. Whenever 0 over infinity, infinity over 0, 0 over 0, you're going to take the derivative of the top and bottom so that you can take the limit. So go back to the L'Hopital's rule, when and how to use it. So let's do the second part. We have to do the second, whether it is a convergence or a divergence. So let me work here. Continue. So the second part was limit capital R approach to the infinity, 0 to r, x times e to the x index. So still, we're going to use the IBP method. So that's going to be u is x, du over dx is 1, du equal to dx. And then we know b prime is e to the x dx. To find out the b, take the integral, so b equal to e to dx. So we have all that information. So according to the IBP, it is going to be uv integral v du. So we have everything there. U x b e to the x minus integral e to the x, dx is a dx, du is a dx. And don't forget the 0 to r everywhere, right? So that we're gonna take a look at that. So what happened? It is going to be capital R e to the r minus the 0, because everything is a 0 for the second one. And then this one, anyway, you will get the e to the x, the same thing. So what I'm saying is x e to the x minus e to the x. The integral of e to the x is the same. So we're gonna get e to the r minus e to the 0. There we go. And then you're gonna take the limit, right? R approach to infinity. So this is going to be 1. So let's simplify. R times e to the r minus 0 minus e to the r minus minus plus 1. That's what happened. So we are going to take the limit of it. I'm going to do the distributive property everywhere. So it is going to be limit r approach infinity, r times e to the r, then minus limit r approach to the infinity, e to the r, limit r approach infinity 1. So check it out. By using the substitution method, this is infinity times e to the infinity. We know that e to the infinity, it is going to be 0. So this is 0 times infinity times 0. So it's not, limit does not exist. So this is actually, limit does not exist. And then this one, e to the infinity, this is 1. And then in e to the infinity, that's a 0. So what happened is infinity times 0 plus 0 plus 1. So that's what happened. Many people confuse infinity times 0. What is it? So I'm going to just give you guys to think about it. Okay. So any number times 0, we cannot define it. So the answer is 0 times infinity, it's actually undefined. So this is actually diverges. So we have diverges plus 0 plus 1, doesn't matter anyway, this is diverges. So we found out this is a diverges, second term. So let me go up. So we found out this is diverges, this is a converges. So let me go back. First term, we got converges. And then second term, we got diverges. The answer is diverges. So final answer, this we just got is diverges. Okay, so this is a little bit challenging question. Think about it. You can definitely handle it, but we're gonna practice more, but this is all you need to practice here so far. Okay. All right, so very similar pattern. Always you're gonna keep in mind, those are 3 cases. Okay, one last question here. I have the same thing from negative infinity to positive infinity. Okay. So we can write it. This is the same as, right? Negative infinity. So this is the third case. This is means limit r approach negative infinity from r to 0. And we have a function b to the 7 dv plus limit r to the positive infinity from 0 to r. The function is 5 minus b to the 7 dv. We want to know whether it is divergence or convergence. So here, I'm going to work on this second part first. Let's see what we're going to get. First, we're going to take the integral, right? So the integral part, we're going to get 5b, b to the 8 over 8, correct? From 0 to r, and then we're going to take the limit. So let's calculate it. This is a capital R minus capital 0. So the limit, we have a 5 times r minus r to the 8 over 8, and then you're going to subtract 0. So everything is a 0. So basically we have this one, and then now you're going to use a direct substitution. 5 times infinity minus infinity to the 8 over 8. So 5 times infinity is infinity, and then infinity divided by whatever number is infinity. So infinity minus infinity is infinity. So this is a diverge. So it doesn't matter whether first term is a convergence or divergence, doesn't matter. Since the second part is a divergence, the total answer is going to be diverges. Does it make sense? So that's what we are doing the third case. And I just want to write down note, many people confused. Infinity plus infinity is infinity, correct? Infinity minus infinity is infinity. 0 times infinity, it's not 0. It's undefined. Okay? So that's why when we up here, 0 times infinity is undefined, which is divergence. We cannot have a limit because it's undefined. Anyway, it's not exist, so it's going to be divergence. So since it is a divergence, -1 plus 1 doesn't matter. It's a divergence. We just proved that this is divergence. So that's why this is important thing you should remember. Okie dokie, are you happy so far? Getting better? I think so. I love to see you guys a thumbs up. Happy, happy, happy. So let me introduce the second concept in terms of the improper integral. Let's go. So the improper integral, as you know, it's a very unique in terms of the range. So here's a more interesting cases. So sometimes it's not just talking about the infinity. Maybe you can think about the interval notation. One thing you should know, if you remember a long time ago, A and B both open means as an interval notation, we are using the open parenthesis. That means we do not include, this is exclusive, right? Whatever the X is between A and B, but we do not include A and B, exclusive. Second one, if you have a block, we are going to include, so big bracket, inclusiveness, we are including A and B, correct? So we're gonna apply this one. Sometimes you have open parenthesis, or sometimes you have a bracket. So what does it mean? If I have, you're gonna find out the interval from the function A to B, but now A is a bracket, B is open. So what does it mean? We do include A, but we do not include B. So this is closed, this is open. So in that case, look at that. You have a function, you are including A, but you do not include B. But so that you're looking for the area between there. You are getting close to B, but never gonna include them. So getting close, but never gonna touch. So that's the case, first one. So if you have that case, A include, B is not included. So what happened? All the left side of B. So that's what we're doing. All the left side of B. From A include all the left side of B. So left side of B. So from A to the left side of B. That makes sense, correct? So that's how you're writing the limit in that case. Another case is opposite. You do now, I'm gonna get rid of it. Now you are going to, or I'm gonna just keep it. Now the second one, you do include B, but you do not include A. So what happened? All the way up, all the right side, this is a from, or I'm gonna say, this is right side of A from the right side of A to B, correct? So then TA to the positive means to the right side of A, and then you actually stop B. So that's the limit, second case. Sometimes you have both include, so it's gonna be much easier. You do include everything. And then you can have some number between their C. So A to C, and then C to B, that's gonna be entire A and B. So the last case, the same thing. Both converges, everything is a converges. If one of them diverges, it's gonna be divergence. So we have 3 cases, the same thing, according to the exclusiveness and exclusiveness concept. So I will show you that example. Here we go, very similar. So this is the question, actually, we're gonna think about it. Look at that interval, right? So we do include 0. We do not include, it's open. So if you look at the image, 0 include, but I do not include 4. So all the way up to 3.99999999999. So this is how you're going to describe left side of 4. So from 0 to 4, 1 over radical 4 minus x dx means with the 0 include 4 open, it means take the limit. It's exactly the first case. So you have t 4 left side of 4 all the way 4. So 0 stop t, correct? And you have the same function, 4 minus x dx. That's how you set it up. That's it. And then we're gonna solve that integral. This is definitely u substitution. U equal to 4 minus x. Du over dx is -1. Du equal to negative dx. Negative du will be positive dx. So now this is integral 0 to t, 1 over radical u, negative du. Okay, so we're gonna take the limit. So this is, we have, this is the same as u to the -1 over 2 du, because the radical is a half exponent. Now you're gonna take the limit, u -1 over 2 plus 1, divided by that summation from 0 to t. So I can flip this one, 2 times u, 1 over 2, 0 to t, right? So that's what I got. And then we are going to take the limit of it. So I'm gonna go back here, so here. So we are taking the limit, t approach to left side of 4, and then we have to write 2. So let me double check. I have negative here. So I'm gonna bring negative, so -2. So that means -2u 1 over 2 d from 0 to t. I can go back to the x variable, which is a -2. U was a 4 minus x. 1 over 2, 0 to t. So actually we have to do f of t minus f of 0. So the limit 4 minus 1. So -2, 4 minus x. We're gonna plugging in t. T 1 over 2 minus -2, 4 minus x. Not x is a 0, because we'll be plugging in 0 and subtract. So limit t for negative -2. This is the radical 4 minus t because of the half exponent. And then I can see this is a negative, double negative to +2. And then this is a 4 radical 4, which is a radical 4. So the limit, we have a -2, 4 minus t. This is a 2 times 2, again 4. Are we okay? So now what happened? We pretty much finish everything. Plugging in 4 into t, substitution. So -2, 4 minus 4 plus 4, that is gonna be 0. So it's gonna be 4 remaining. Limit exists. That's all you need to check. Limit exists. So this is convergence. So that's how you do it. So it's the same strategy what we done. Check it out, whether it is a convergence or divergence, you can definitely try it. Okay, so I'm not gonna do too much work here because you can try it. I'm gonna skip this one, try this one, check it out, whether it is a convergence and divergence. So this is one, include, this is not include. So check it out, which one you're gonna utilize it. I'm gonna quickly do the last question. Hang in there, almost done. So the last concept in terms of improper integral is a comparison theorem, okay? Or many people say this is a squeeze theorem or sandwich theorem. So the concept is you have a two function, f and g, or you have a relationship f and g, two function. And then what we're gonna do, I wanna know where the g function is heading to, whether it is divergence or convergence. So the theory is from the sandwich theory. If you have a g is between f and h function, all right, and then there's a specific order, g is a sandwich in the middle. So if f and h is a divergence, g is gonna be automatically divergence, right? If f and h is a convergence, g sandwich is automatically convergence. So that's all you need to know, comparison theorem, sandwich theorem. So the formula is a little bit there, but you don't need to memorize anything. Just think about the sandwich. Okay, this is in the middle. Both of them diverges, middle will be diverges. If it is both of them are converges, the middle is gonna be converges. So I will just take a look at the example. This is the something I wanna prove. So let's say this is the middle sandwich function, and then we're gonna consider this is something between middle. So first step is, here we go. Whatever this function, whatever you're plugging in a number into x, this function is always gonna be positive, isn't it? Because in this question, we have specifically starting from 1 to infinity. So I can set it up. 1 over x times e to the x is greater than 0 because it's a positive function. And then if you think about it, 1 over 2, 1 over 3, this is a larger, correct? So if you get rid of one of the term, like for example, 1 over e to the x, this function is always smaller. Let's compare. 1 over, so we have 1 over x times e to the x, 1 over e to the x. Let's compare. When x equal to 1, this is 1 over 1 e to the 1, same. But when x equal to 2, 2 times e to the second, so this is getting larger, so they are getting smaller. So this relationship is true. This is a larger. So as x is increasing, this function is always larger. So we can set up this relationship, right? So all you need to do, check it out, where this is heading. Actually, this is already 0. It's gonna be converges, but let me double check. So we are going to check where they're heading from 1 to infinity. So now we are going to take the infinity, 1 to infinity, 1 to infinity, 1 to infinity. So I'm gonna work on, because this is complicated, this is much simpler. So we are going to 1 infinity, 1 over e to the x. This is the same meaning by taking the limit 1 to r, 1 over e to the x dx. So this means limit r to the infinity. You can a little bit e to the negative x. That's the same thing. And then I'm going to keep going. Take the limit, or take the integral. It is going to be negative e to the negative x. Because if you remember, integral nx e to the nx divided by n. So n is a negative 1. So we have this from 1 to r. So now limit r approach infinity, negative e to the negative r minus negative e to the negative 1. So now limit r to infinity, negative e to the negative r, double negative, positive. So now I'm going to plugging in infinity to the r, negative infinity, plus e to the negative 1. So do you remember? This guy will be 0. And then this one plus 1 over e. We have 1 over e exists. Limit exists as a 1 over e. So what happened? This is a convergence. So therefore, we prove that since this is going to be convergence, the middle sandwich also going to be convergence. because the relationship is true, okay, because of that order. So therefore, that's the sandwich theorem. Just find out some function, that is a smaller or larger, with the middle function, and then check it out. Both of them are converges, it's converges. Both of them are diverges, it's a diverges. But we need to already know 0 is going to be 0, convergence. But this one we need to check as well if it is a convergence or not. So that's the work. So we finished 3.7. I hope everything is going well. So far we finished chapter 3. Okay, so finish all the quizzes, and there are embedded video you can watch all the time. I hope you are enjoying watching my and every resources. We have available resources. So you can always participate in the discussion chapter 3 if you have any question. So feel free to join and let me know if you have any question by email. Okay, thank you everyone. I will see you in the next video. Bye-bye.